Hey, what's up? It's your old pal, Mr. Cook. We just got through the first 9 problems. Now we're on number 10. We just finished up our first related rates problem. It was 2 parts, Pythagorean theorem, right triangles, all that stuff. It was a lot of fun. Now we're on to number 10. So 10 has its own diagram drawn up for us, and wouldn't you believe it, we've got another right triangle in there. So, we should remember our right triangle stuff. So Pythagorean theorem, area of a right triangle, 1/2 base times height. Maybe a little bit of trig would be helpful to know as well, sine, cosine, tangent, all that. I don't know. Let's read through the problem and see what's necessary. What do we need to know? A construction worker pulls a 5-meter plank up the side of the building under construction by means of a rope tied to one end of the plank. There's got to be better ways to do that. I don't know, but whatever. The plank, it doesn't look like it's going to change length anytime soon, so it's going to be stuck at that. So, that's something to consider as well. Assume the opposite end of the plank follows a path perpendicular to the wall of the building, and the worker pulls the rope at a rate of 0.15 meter per second. So that's nice. If it's perpendicular, that means that we've got a right triangle for sure. And we got a rate also because we got meters per second, which is pretty cool. So we can figure out what that means in a second. How fast is the end of the plank sliding along the ground when it is 2.5 meters from the wall of the building? Okay, so obviously we've got a right triangle here. Let's define some variables for all of these. We've got the plank, the length of the plank, the distance away from the plank base is from the wall. So that's this segment here. We'll call it distance, capital D. And then also how far up the plank is along the wall. So that's this length. Let's call that, I don't know, H, height along the wall or something. Obviously, these are related with a right triangle. So H squared plus D squared is equal to P squared. From this, the way to relate the rates is to, take the time derivative for all this stuff. But I might need the following. Since I have 3 variables, I might need dH dt and an H value that goes along with it. I might need dd dp or dd dt and some distance, that it is away from the building or the construct. And then also the rate of change that the plank is, changing. But obviously, the plank isn't going to change, length anytime soon. It's stuck at 5 meters, and that means it's not going to be changing at all. All right, so let's try and fill in some of these blanks that we have. The plank is 5 meters. We know that. The 0.15 meter per second. It says that's for when. What does it say? Assume that the opposite end of the plank follows a path perpendicular to the wall of the building, and the worker pulls the rope at a rate of 0.1. So if the worker's pulling the rope that way, right, that means that it's this direction, that thing, the dH dt that they're talking about, and H keeps increasing as the worker keeps pulling it up. So that means that it's gonna be a positive 0.15. And then it says how fast is the end of the plank sliding. Well, this is probably the rate that we're looking for. We're probably looking for this guy right over here. So that's our target. And then how fast is the end of the plank sliding along the ground when it is 2.5 meters from the building. So that's this distance, away from the building. So that means that D is going to be 2.5. All right, so since H, D, and P are related in this way, and I've got 2 of the values, 2 and 5, I can just use Pythagorean theorem to solve for the H value. So if I do that, H squared plus D squared, so 2.5. Let's convert that to a fraction. 5 over 2 squared is equal to P squared, which is 5 squared. So squaring all that stuff out, I get, 25 over 4, and then 5 squared is 25. And if I subtract that away, so let's see what that would be. H squared equals 25 minus 25 over 4. So let's find the common denominator. If I multiply the top and the bottom by 4 on here, 4 times 25 is 100. And then 100 minus 25 is 75. So 75/4 is what I get for that. And you can do that on a calculator if you want. It's not a big deal. We take the square root of both sides. H is equal to plus or minus the square root of 75 over 4. Obviously, we're not going to need the negative value because of the height. And then we take the square root of the top and the bottom. The square root of 4 is 2, so 2 is in the denominator. And then square root of 75, well, 75 is really 25 times 3. And if I take the square root of 25, that's 5. So this becomes 5 square root of 3 over 2. So 5 halves square root of 3. So whatever that number is, that's what H is. Okay. And I don't really care what that number is because it's just something for me to plug in at the end of the day. All right. So I got to use implicit differentiation and find the derivative of this thing. So let's do that. So implicit differentiation for h squared plus d squared equals p squared. I get 2h and then dh dt, and then 2d dd dt, and then 2p, and then dp dt. Okay, let's start plugging some of this stuff in. The h value is 5 square root of 3 over 2, so 2 times 5 square root of 3 over 2. And then dh dt is 0.15 plus 2 times d, the distance, d is going to be 2.5 from the wall. And then dd dt, we don't know what that is, so we're going to solve for that. And then 2 times the plank's length is 5, and then dp dt is 0, so that just stays 0. So that part's going to be pretty easy. That's just going to become 0 overall. Let's start simplifying this a little bit. Now the 2's cancel out there. And what is 0.15 as a fraction? That's let's see, 15 over 100. I guess I could simplify that a little bit more. Let's see. If I divide the top and the bottom by 3, I get 5, or divide by 5, I get 3 over 20. That can help me out at all? 3 over 20? Yeah, that might. Okay. So I'll just rewrite that as a fraction, 3 over 20. And then let's see, the 5 and the 20 will cancel out, getting me a 4. So looks like, that whole thing just reduces down to 3 square root of 3 over 4 as a total. And then let's see, 2 times 2.5, that's 5. So plus 5 d dt. And then that's equal to 0. Now let's solve the rest of it. So we can subtract one of them away. Let's do subtract this part over here. So we get 5 d dt is equal to, subtracting that away gives me a negative 3 square root of 3 over 4. And then the last thing is I just got to divide by 5. So I get d dt is equal to negative 3 square root of 3 over 4 times 5. So I just divided by 5, right? Okay, so let's see what that is in our calculator. We'll round to a couple decimal places. Negative 3 times the square root of 3 divided by 20. That's going to be negative, okay, so let's see, negative 0.2598. Okay, so let's write that in, and then we'll put the units, and that'll be it. So it's negative 0.2598. And then what was it? It was, I think, meters, right? Yeah, meters per second. And that's our answer. There we go. All right, that was a fun one, number 10. That looked a little bit confusing just because of the, I guess the worker pulling the rope up. But once you realize it's just another right triangle, and it's pretty easy. And let's see what 11 is. 11 we'll do on the next video, but I like to look at them too. Let's see a boat. Oh, this is another right triangle one. Can you guys already see it? There it is. So probably another Pythagorean theorem and all that stuff. All right, we'll see what it looks like in a second. That's it for this video. Thank you very much for watching. I hope you found it helpful. If not, just go find your math teacher, your calculus teacher, whatever. My name is Mr. Cook. I'm always available to help, so find me in the morning or after school, and I'll do my best to work with you. Okay. Thank you so much for watching. I'll see you in the next video. Bye-bye.